Howdy class, we're going to look at formatting our output now. This means that when we output various numbers, we can control how that output is formatted by using a variety of formatting instructions. We'll call those format specifiers. Now, Python 3.6 introduced F strings as sort of the new and improved way of formatting output. Before that, there were these two methods, and you may see these out in the landscape, in the coding landscape, where you can use the % to just list out your format specifiers. There's also a .format function that was used to specify all of our output specifiers. But we're not going to do this anymore. As a matter of fact, I'm not even teaching it any longer since Python 3.6 introduced this new way of doing it. And it really does simplify the equation. So these are just not even going to be discussed today, just F strings. And they're quite simple. Normally in a print statement, if we had a print statement like this, print, and we wanted to just print out the value, let's say we had a string or some kind of a variable named val. Well, we could do that and it'll print out the variable just fine. The other way to print things consecutively is to do something like this. So rather than just printing, and let me backspace a little bit there, you could also print, the value is, and then close that string, put a comma in there, and then you could simply say val, and that would print out. This is just like native variable output, along with some type of a label or string that's going to accompany that output. Now, the new way with F strings is making it very, very easy. Rather than having to wrestle with outputting a string and then using a comma and then outputting a variable and then continuing that process if there's more than one, rather than doing that, we're just going to substitute in a little placeholder syntax that's going to represent the value that we want. So let's say here we've got value assigned as 10. So this is an integer variable. It was assigned the integer literal 10. And what we can do with F strings is now, rather than printing out this way, what we do is we do the normal print statement and we add an F in front of the string. But you'll notice that the string is the entire line, meaning we're going to print out this entire string. Punctuation and spaces, all the same. We're going to print out whatever's on that line between the two single quotes there. Now then, to print out a variable, since that's not going to be part of a string that we could easily access, what we do is we just simply put in the variable name inside braces, and that serves as a little proxy in the print statement for that variable. Here's another example down here showing, well, what if we've got two variables? So here's a Python statement that will assign the values of 10 and 15 to the variables val1 and val2. And yes, in Python, you can't do this in any other programming language, but in Python, you can do kind of multiple assignments like this, where if you list val1 first, that's just going to be assigned the first value that you mentioned. If you then do an assignment for val2, that's going to then take the second literal that was mapped to it. But look at what we do here then in our print statement. It still opens with an F, and then we have a set of single quotes, and then a set of parentheses. And whatever we print in the middle is going to be output. But now we've got 1, 2 variables that were properly declared and assigned some value. These will print out there. Let me show you this code now in action in Jupyter Notebook. And you'll see it making a little bit more sense. In our Jupyter Notebook now, we see this first cell is containing one variable that's going to be output, val. And again, we put that inside our braces and then just output that string. Now, a nice easy way to kind of get used to doing this is by typing the word print, of course, and then putting in F, single quote, close parenthesis, just to get the syntactic elements typed out first. So now all you have to worry about is populating what's between the single quote marks here for what you're trying to output. And you see there that the value is 10 is output, no problems there. Here's that code that we drew on the board, assigning V1 is 10 and V2 is 15. And this shows how we can then output two different variables inside of a single print statement using F strings. Again, don't forget to put the character F in front of our single quote pair. So this will delineate the F string print method and not any other method. Okay, now let's look at format specifiers. Now with output formatting, we can really tailor our results by using a combination of these format specifiers. You can use them in many, many combinations. Now, the way we do that, you remember that when we output a variable, let's say it's var, in the middle of a printing out an F string that kind of looks like that. What we're going to do now is right after var, right here, we're going to just insert a colon, and then we're just going to list some format specifiers to modify the output the way that we desire. Now there's four general classes of these specifiers. The first is going to be a width specifier. That's going to say, okay, what's the field width that you want to print this thing out in? So for example, if I have a variable that's 152, and I tell it to print out in a field width of, let's say 6. Well then, what is actually going to be print out then is a field width that is 6 characters wide, 1, 2, 3, 4, 5, 6 characters wide. And that 152 then is going to fit inside that field width, and we'll tell it which way we want it to be aligned, either to the left or to the right. We'll tell it that. But what this does is it allows us to line up numbers very easily. Let's suppose, for example, that you've got this number to output, but you want to print it out in a nice even column that's right justified. Maybe the next number is these. Well, we can get these to print out right justified, all beautifully aligned. First, just by specifying, well, what is the field width that we want those printed out in? And you want to take the largest number and give it a couple of spaces of padding. So let's say we printed this out in a field width of 8. Well, then all of these will be output in that field. And if we use a right or a left justification symbol, we'll see how these all line up. So let's go back to the other page there. So that's how we get a format specifying the width of the column that we want. Now, the second thing that we can output here is whether or not we want the comma separator to be included in the output. Let me erase some of this stuff. Hang on a second. So a comma separator is exactly what you guess it is. We can put, we can make our output like 153,654.2. And you'll note here that this comma was placed because we told it as a format specifier to output the comma. So that's what that's going to be. We can also specify what precision we want. Oops. There we go. What precision we want, meaning how many decimal places do we want to do? If we had a number like this, 4, 5, 6, 7, well, we only wanted 2 decimal places. Well, we can use a format specifier to tell how many decimal places we want. And rounding is going to be a normal part of that operation. It's going to round it like normal. So if we wanted 2 digits here, well, then we would use a precision specifier. And that'll also be in combination with a type specifier for what data type the variable is that we're trying to print. So the way that we do these is that we just are going to put all of those specifiers right here after the colon, and that colon is after the variable name. And all of this is contained neatly within the curly braces. The order in which that we have to do these is this order right here. The width comes first, then comma, then precision, and then type. Now, they're not all required. Maybe you just want the precision one, and that's fine. Or maybe you want to mix and match and just do a width and a precision, but no comma, and that's fine. Or maybe you just want a comma, then that's fine also. But you put them in this order, and the interpreter is smart enough to know exactly what you need. So let's review the syntax now. For rounding, all you do is put decimal and then how many decimal places of precision you want. In this case, we wanted 2, so the specifier would be a decimal 2. Now, we also need to put in an F there just to denote that we're manipulating a floating point number. If we ever had to use a decimal, well, we would use a D for decimal. I'll put a D up there for decimal. But we'll primarily be doing this to floats because that's the precision that we want to get. For commas, all we do is right before the rounding, we just put the comma in there. We can also format as a percentage. And we do that simply by right after the precision specifier, we would make the type as the percentage type, and it would automatically convert that to percentage. Now, field width goes first here. So the very first thing after our colons, if you have an integer right there, that's always going to denote a field width. And let's say we did 10 like that. Now, there's 2 modifiers to the field width, and that is the less than sign and the greater than sign. If you precede a field width with less than, like this, colon, colon, less than 10, that's going to left align your output. So if we go back to what this looked like, left aligning our output would look like this. And that's fine. Maybe we would want to have another field width. Let's say that this is a field width of 6. So we used the format specifier less than 6. Maybe right after this, in another new column, there's some more data. And then we would just put that in a format specifier also. We would just put it in a field width of 6, so that would be another less than 6. If we wanted to make this right justified, we simply put in the greater than sign, and that will justify it to the right. So here's some examples of combinations down here that we can look at. Here we have a series of format specifiers, a 12, a comma, a decimal 2, F. So this is saying use a field width of 12 here. That's where our 12 comes from. Use commas, because we put the comma in there. And then round, so we use 2 places of precision, and I should say 2 decimal places of precision. This other example here is saying, okay, a field width of 6, the first integer is always the field width, then give me 4 decimal places of precision. All right, well, let's take a look next at some code that's going to reinforce these principles. Okay, we're in Jupyter Notebook now, and we've got some values up on our screen. And let's just start to manipulate these. First, I'm going to increase the font size a little bit there, just so it's more readable for you. All right, well, let's start to print these out in various formats. First, this is the native format. It's just going to print it out. If I print out the floating point number that's got a lot of digits. Oops, let me rerun these. That's the thing about Jupyter Notebooks, is that if you create variables up here, you have to run those so those variables then go into memory. Especially later in your notebook, if you go and access those variables, they've got to exist in memory. So you just saw what an example is where it wasn't in memory, so it didn't know what V6 was. Okay, here I just printed out V6 in its normal native format, and we got every decimal place of precision that there is. Let's say, though, that I want to now print, let's say, a little label such as that. The value is. Well, as I mentioned, in braces, we then put the variable name and we get then the label output plus the value. Pretty simple there. We could repeat this even. And maybe we want to just say V6 is this, and let's pick another variable. How about V3? And V3 is, and we'll put V3 then in those braces. And now we get that full string presented to us. Now note here that anything inside this string that's, again, bound by single quotes is going to be output, including all spaces. So make sure that you pay attention to your spaces. If you put a whole bunch of them in like that and ran that, well, our output is going to have all of those spaces in it. Or similarly, if you forget to put some spaces around your variables like that, well, then all of our output will sort of get munged together. So you need to make sure that we've got it nice and evenly spaced out there. All right, well, let's take this code now, the same code, and let's start to really modify it with some of our specifiers. The first is, let's do the format specifier for decimal places for this floating point number. And let's do a 0.3f, just like that. Run it, whoops. Run it, and now we see that the output is 1044.368. So we did get those 3 decimal places of precision. How did we do that? Well, we put these format specifiers in. The very first thing is the required colon. And then in this case, we put the .3f to show that this is a floating point number that we want. And we're going to use 3 decimal places of precision. Let's say if we don't want any precision, well, we can put a .0f, and it's going to just round that up then to the nearest integer. Let's say that we want 9 places of precision. Well, since the value did not have 9 decimal places, what we'll get is some padded zeros at the end there. So that's showing that. Let me show now with V3 here. Perhaps we want the comma separator for that. So it's going to be 1,652. Well, let's put our colon in and then just a simple comma. Run that, and we get 1,652 with the thousands separator. Let's say we wanted to take the value of V3 and square it, and then output that, and you get the number there, 2,729,104. So you see here that, yes, inside of one of those braces for these output specifiers, you can actually do math in there. You can put a mathematical expression. And then just whenever the interpreter reaches that colon, it's going to start to specify the output. Now let's look at the right and left specifiers. We've got a couple of values here, V1 through V4. And let's say that we want to get these output in a nice, even column. There we go. Here's just a bunch of regular print statements. All we're doing is outputting the variable. And you'll see that by default, we get this left justification. Left justification. Now we can change it. Let's put in our colons to indicate, hey, we've got some format specifiers coming. And let's try this now with some field widths. Let's try a field width of 10. And we're going to right justify that. Well, look at how our output now is aligned. It's aligned to the right. You know, the tab stop has got the numbers like this, and they're all kind of evenly lined up there. And if we were to count this number of spaces, it'd be 10, because that's the field width that we specified. Now, by default with Python, whenever you specify a field width, the default is always going to be right justified. So I took out all of those greater than signs, and you can see here that the output went to right justify by default. So just remember that behavior. You know, you only would need to include that greater than sign. You know, maybe you've got some previous code that was left aligned, and now you have to make it right aligned. So that's how this works here. And then certainly we could put in left alignment here. And it goes back to left align. However, if we were to print something else out, you know, this left alignment is still in a field width of 10. So let's say that we wanted to print out something else here. Just like that. Well, when we run that, these characters, this string something else here, look at that, it started way over. It didn't start right after the 1, 2, 3. And that's because we printed out 1, 2, 3 in this field width of 10, so it occupied 10 spaces. If I take out that and run it again, well then the 1, 2, 3 gets right justified, and now they're sort of munched together because that's exactly what we told it to print. Maybe we put a space in there, run it again, and our output's a little bit more manageable. So that's a way to get things lining up. And if you had, let's say we had here a V7 and a V8, and let me run that again real quick. Well, let's do the same thing now with these floating point numbers. Let's get those to align up nicely. And the way we do that is we have to first make sure that we have the same number of decimal places. That way the decimal would all be lined up, and then everything else could be right justified. So let's look at some code how we could do that. Okay, there's V5. So there's V5 just printed out. Let me get in then 6 and 7 and 8. So natively printing out normally, there it is. It's all left justified and somewhat jumbled. So let's do a couple of things. First, let's put it in a decent field width of, let's say, 12. Okay, so I'm going to put a giant 12 after each of these colons, since the first integer always denotes the field width. Next, let's decide how many decimal places we want. So I'll do let's say a .1, because I just want one decimal place. So it'll do rounding. And when we run this, we see that we get all of our numbers aligned here. Now, we left out the data type here in our 0.1, and it's very interesting to note, well, what is that? What's that jumbled mess there? Well, that's just scientific notation. And if you leave out the floating point number designator or the the integer designator, so that's either an F or a D, well then you may get scientific notation output as the default. And that's just a feature of Python. It does that. So let's put our Fs back in to show that, yep, we wanted floating point numbers. And now you see, okay, we got the floating points output. But look, they all have one decimal place of precision, and then all of the decimal places are beautifully lined up. Pretty cool. Let's say we wanted to do the same thing, but we wanted to do it in columns of 2. So now if we wanted to have 2 columns and then there'd be 2 rows, since there's 4 values, well, let's just print out then the other variables like this in their own proper places. And look at this output now. We've got almost sort of a spreadsheet idea going, don't we? We've got the first number printed in its field width of 12. We got the next number then on that same line printing out with its field width of 12, and then we repeat that for the next row. And the way we do that is just simply, there's the variable that we want to output, followed by the very next variable that we wanted to output. You'll note here that I didn't put any spaces in here. You certainly could, but you don't need to, because you can account for how many extra spaces of padding you want just in how large your field widths are. So that's going to be really a delightful way to get numbers to align. Okay. Okay, here's some code now that we want to use to try and sort of print out a receipt of some type. Let's say we've got a receipt with some items in it, and we've got a subtotal, a tax, and total. How would we print that out? Well, let's take a look. First, I'm going to create a constant for tax rate, and we'll use 0.088% tax rate, whatever state this applies to. Then I've got a couple of string variables, and these are going to serve as our labels. A label is going to be an accompanying string to describe what the number next to it is. So in our receipt example, we've got a couple of labels for subtotal, tax, and total. And note that I do go ahead and put in the colon as part of that string. So there's our 3 labels. Next, I'm just going to do some simple calculations. Let's say that our subtotal was $152. I'll then have the program calculate the tax, which is just that total times the tax rate. And then the total will be the subtotal plus the tax. Now, we want to get this format so it looks like a good looking receipt where the labels are all right justified, and then we tab over and the values themselves are also right justified. Now I'm going to first remove these to demo what happens. Let's just take the first line alone. Just look at the first line, because the others are formatted exactly the same. Okay, this is saying that we've got these curly braces here. So it's saying print out label 1 in a field width of 12. That's all it's saying. And that's exactly what happened here. Subtotal got printed out in a field width of 12. Now you'll note here, there's a difference with format specifiers for integers and strings. I'm sorry, floating points and strings. If you don't put in the left justify or right justify operator, which is again the the less than sign or the greater than sign, with a string, it's going to left justify by default. With a number, it's going to right justify by default. So here I've got none of those less than or greater than signs in here, and you can see that the behavior is, well, the strings all go to the left and then the numbers all go to the right. But I don't want that. I want right justification for these strings. So I'll just put in the right justification operator there. And we saw here how subtotal, tax, and total then go and get right justified. Then after that number is printed out, we output the value. So subtotal is the name of the variable. And we're saying here, print it out in a field width of 15. and then use 2 decimal places of precision and output this as a floating point number, not in scientific notation. So when we run that, we see that we get this really nice alignment, and it's looking kind of sharp and organized and professional. Okay, gang, so I hope that this helped with format specifiers, and keep going on the videos for a lot more this week.